Hello and welcome to Live at PALS for another GED Science screencast. Today we will go over a full GED Science test. So I hope this will help you to prepare for your science exam, and we get into it right now. So the first question is a question about lift and weight. And the question refers to all the information we get here. So Newton's third law of motion states that when one object exerts a force upon another object, the second object exerts an equal force on the first object in the opposite direction. An airplane in motion changes the speed and direction of the air exerting a force on it. The opposing force of the air keeps the airplane aloft. So here we can see the wing of an airplane, a cross-section through it, and we can see the direction of motion of the airplane, and then we can see the forces that are exerted on the wing by the airplane, the weight, and we can see the lift that the airplane experiences. What vertical force holds the airplane up in the air? Lift, Newton's third law, weight, air resistance. So one we can definitely cross out immediately here. That is Newton's third law, and that's not a force. So the other three are forces: lift, weight, and air resistance. If we look at the illustration that we are given here, we can see that the force that holds the airplane up in the air is the lift force that outweighs the weight of the airplane. The lift force is greater, therefore the airplane is rising. So the correct answer here is lift, and the other answers are wrong. So that is the correct answer, lift. Sleep may have evolved in humans for several reasons. First, people were unable to hunt, gather food, or travel in the dark. Second, sleep provides an opportunity to repair our body's cells, especially those in the brain. Third, our body temperature is lower during sleep, which conserves energy. Fourth, during deep sleep, the pituitary gland releases a growth hormone, so sleep may play a role in growth. Which of the following is the best title for this paragraph? Sleep and growth, our brains during sleep, why we sleep, the role of deep sleep. So a couple of things we can probably cross out here. So if we look at the first answer option, sleep and growth, there is something in the paragraph that talks about sleep and growth. It's specifically the fourth possible answer to why sleep may have evolved in humans. But the other three are not mentioning growth, so that would be just a title for the last sentence, for the fourth option, but not for the whole paragraph. So we can cross that option out. Our brains during sleep. So here that's very similar. Not all the answer options, not all the sentences, possible explanations are about the brain. So let's cross this one out too. Why we sleep, that sounds promising. And the role of deep sleep, again, just one of the four possible explanations is about deep sleep, not the others. And why we sleep is a good title because we have four potential explanations, for hypotheses why we are sleeping. So that seems to be a good title for the paragraph. So for this question, we have to do some math. A scientist shines a laser through 6 beakers, each containing a different liquid substance, and measures the laser beam's angle of refraction. The scientist records some measurements for liquids A to E in the table below. A measurement for liquid F is lost. However, the scientist recalls that the mean of all 6 angle measurements was 23 degrees. What must the laser beam's angle of refraction through liquid F have been? So we get some information here. We know that the mean is equal to 23. And we know that we can find the mean by taking the sum of all measurements and divide that by the number of measurements. So we know that 23 is equal to 15 plus 32 plus 12 plus 47 plus 15 plus x, our unknown value, divided by 1, 2, 3, 4, 5, 6 measurements. So we can take the sum of the numbers that we have first, and that is 121. So we know 23 is equal to 121 plus x over 6. And now we can find the missing value. We move 6 over to the other side. That is 6 times 23 is equal to 121 plus x. And that is 138 equals 121 plus x. And now we can subtract the 121. 138 minus 121 is equal to x, and that means x is equal to 17. That is our missing value for f. So what you definitely need to know in this case is you need to know the formula of how to find the mean. We sum up all the measurements that we have, and then we divide by the number of measurements. And you need to be able to do some basic algebra here to solve this equation to find x. Okay, question 4 through 6 are based on the following information and graph. The processes that circulate nitrogen between the atmosphere, land, and organisms are called the nitrogen cycle. So here we have a quite detailed diagram of the nitrogen cycle. You can see that nitrogen in the atmosphere can get into the soil by nitrogen oxides that are dissolved in the rain, or dead animals and animal waste or dead plants get eventually broken down to ammonia or ammonium, and then we have nitrite bacteria in the soil that change it to nitrite, nitrate bacteria in the soil changing it to nitrate, and that makes it available to plants again to absorb. We have as well denitrifying bacteria that change nitrate, ammonia, and ammonium back to atmospheric nitrogen gas. And we have one more type of plant here, which is able to nitrogen in the air, enters air spaces in the soil, and there nitrogen fixing bacteria on legume roots. Legumes are a specific group of plants that have these nitrogen fixing bacteria in their roots, and in the soil fix nitrogen from the air and in the rain so it can be used by plants. So nitrogen fixing bacteria, so that's what the question is about, that part here. are found both in the soil and on the roots of legumes like peas and beans. From where do these bacteria get nitrogen? And they tell us right here, from the air in the rain. So the correct answer is B, the air and rainwater in the soil. Which of the following statements is a conclusion about the nitrogen cycle rather than a detail in the diagram? Nitrogen oxides dissolve in rainwater. That is a detail from the diagram. Nitrogen-fixing bacteria are found both in the soil and on the roots of legumes. The recycling of nitrogen through the biosphere involves many complex processes. Nitrite bacteria turn ammonia and ammonium into nitrites. So we can see this is another detail from the nitrogen cycle. These bacteria turn ammonium or ammonia into nitrite. And nitrogen-fixing bacteria are found both in the soil and on the roots of legumes. It's another detail from here. And a good conclusion about the whole thing is that we have many complex processes that are involved in cycling nitrogen through our biosphere. So the correct answer here is C. To increase the nitrogen content of the soil, many farmers spread synthetic fertilizers containing nitrogen compounds. What might an organic farmer who does not use synthetic fertilizers do to improve the fertility of the soil? Switch to crops requiring more potassium, compost with plant and animal wastes, plant more non-leguminous plants, switch to crops requiring more nitrogen. So in general, the idea of fertilizer is, again, to add nitrogen compounds to the soil so that plants can assimilate their nitrates and grow healthy. Usually on farmland, nitrogen is depleted over time because we harvest the plants, and the nitrogen in the plants therefore disappears from this region and it cannot get recycled. So whatever we are taking away from the land that is being used needs to be added to it again. That can be done by using synthetic fertilizer or by other methods. So which of these four answers adds or will add nitrogen in a certain form back to the soil that is organic? So what will not add nitrogen is switch to crops requiring more nitrogen. That would deplete the soil of nitrogen even more. Plant more non-leguminous plants. That would have the same effect. Non-leguminous plants will absorb nitrogen from the soil. Another option would be to actually plant leguminous plants, because they are plants that absorb that have the nitrogen-fixing bacteria which absorb nitrogen from the air and change them into nitrogen compounds. And these plants could then be allowed to grow on a field and eventually cut them down and let them decompose, and that will then add nitrogen to the soil. And that is basically answer B, just in a different way, that compost with plant and animal wastes. So here we have plant and animal wastes. They will eventually be turned by decomposers into ammonia or ammonium, which are then by several steps turned into nitrate, which is then available to the plants that grow on the field. So the correct answer here is B. Now, A does not make really sense as well. Switch to crops requiring more potassium. That does not mean that these plants will not need nitrogen as well. All plants need their nitrogen compounds to grow healthy. Question 7. refers to the following graph. Solubility of common compounds in grams of solute per 100 milliliter of water is shown here. We can see 3 different salts and how their solubility changes with changes in temperature. It's covering the graph a little bit here. So let's move this down a bit. So we can see as temperature increases, 3 different salts solubilities change, and in general we can see that they are all increasing but at different rates. The y-axis shows us the solubility in grams per 100 liter of water at different temperatures of the water. Which of the following statements is supported by the information in the graph? About 15 grams of sodium bicarbonate will dissolve in 100 milliliter of water at 10 degrees Celsius. Okay, let's check that. Sodium bicarbonate, that's what we have here. At 10 degrees Celsius, that is about 7 or 8 grams that will dissolve. Not 15 grams. About 30 grams of potassium chloride will dissolve in 100 milliliter at 30. Potassium chloride at 30 is about 36, so that is more than 30. Sodium chloride shows the greatest increase in solubility with the increase in temperature. It does show the lowest increase. We just look at the starting value and we check by how much does the solubility actually go up, and that is just a very, very small amount in this case, maybe 1 gram. Now the greatest increase would be potassium chloride. We can see the total change, total increase or change in solubility is this much. So the correct answer must be D. For the 3 compounds shown, solubility increases as temperature increases. Yes, all 3 have their solubility increased as the temperature increases. All 3 graphs have a positive slope. All the lines are going up, showing an increase in solubility with increasing temperature. Following the scientific method, a researcher conducted an experiment using houseplants. Match each action the scientist took to the steps in the scientific method below. So here we have the 5 steps of the scientific method. The first step is to formulate a question about a phenomenon that has been observed. Then we would collect data. Then we would form a hypothesis. Then we would test our hypothesis through an experiment, and then we would draw a conclusion. Although we could argue to eventually swap these 2 steps here, very often a hypothesis is probably formulated before the data has been collected. But it can be done the other way around as well. So let's look for step 1, formulating a question about a phenomenon. Let's read our 5 prompts that we have here. For 6 weeks, the scientists used water at 75 degrees to water plants in group A and used water at 55 degrees to water plants in group B. He recorded their growth during this period. So this sounds either like data collection or like experiment. The scientist wondered whether water at different temperatures might affect house plants differently. That could be our question. It has been formulated. Maybe it could be a hypothesis. The scientists researched the growth rate of plants at various greenhouses, some of which use cool water and some of which use warm water to water their plants. could be formulating a question about a phenomenon, or maybe collecting data. At the end of 6 weeks, the plants in group A were on average 2 inches taller than plants in group B. The scientists interpreted this to mean that warm water is better for plants than cool water. That sounds very much like a conclusion. The scientists guessed that warm water might be better for plants than cool water. That is very likely the hypothesis, although it is not a very good formulation of a hypothesis. So very often a hypothesis is described or simply defined as an educated guess based on background knowledge. That is probably what they mean by collecting data here. Something better to say than collecting data would be do some kind of background research about your question and the phenomenon that you have observed, and just to gain more knowledge and become an expert in the field to be able to formulate a good hypothesis. So a hypothesis is not only an educated guess, but it is important that a hypothesis is formulated in a way so that it can be tested by an experiment. So the question, what makes most sense here is the scientists wondered whether water at different temperatures might affect houseplants differently. So this is our phenomenon, this is our question. And that leaves us with C for the background research. The scientist researched the growth rate of plants in various greenhouses before he did his own experiment, some of which use cool water and some of which use warm water to water the plants. And we are formulating our hypothesis, which was E. The scientist guessed that warm water might be better for plant growth than cool water. And then he conducted his experiment, which is for 6 weeks. The scientist used water at 2 different temperatures, 75 and 55. Well, that is probably Fahrenheit, not degrees Celsius. That would be a bit warm for plants. And that is our experiment. So here we have the correct order of the actions of the scientist. Atoms are composed of protons, which have a positive charge, neutrons, which have no charge, and electrons that are negatively charged. Because an atom has an equal number of protons and electrons, it has a total charge of 0. What would happen if an atom lost an electron? If it loses an electron, that means it loses a negative charge, and therefore it has one more proton than electrons, and therefore it has a positive charge. So the correct answer is A. Its charge would become positive. The other answer options don't make sense. Weathering is the breaking down of rock by rain, frost, wind, and other elements. No transport is involved in weathering. The weathered rock remains in place. Weathering can be physical, involving abrasion, the weathering away of a surface, or changes in temperature. It can be chemical, involving chemical reactions, or it can be organic, involving the action of living things. Which of the following is an example of physical weathering? The cracking of granite from the expansion of freezing water, the breakdown of calcite by reaction with acids in fertilizer, that is chemical, reaction, the transport of sand by the wind. And we've just learned that weathering is a breakdown, but it does not involve transport. That would be erosion that happens after weathering. So, no transport. The breakdown of crumbling rock in the soil by burrowing worms. That would be an example of organic. Worms are living things. So the correct answer is A, from the expansion of freezing water. That is something physical. Changing state is a physical change. When removed from the body, large organs live only a few hours or days under cold conditions. Therefore, organ transplants must be performed quickly. Many organs go to waste because the organ cannot be transported to an appropriate patient in the short time available. Unfortunately, it is not yet possible to freeze large organs to preserve them for a longer period. That's because they contain many different types of cells, all of which react differently to freezing. Some cells are even destroyed by the ice crystals that form during freezing. Which of the following studies is most likely to yield information that might help solve the specific problem of freezing whole organs for transplant? How the time it takes to locate patients who need organs can be decreased. That has nothing to do with freezing. It's probably not correct. How the time it takes to transport organs to their destinations can be decreased. Again, this has nothing to do with freezing. Let's see where this goes. How special fluids keep insects alive during sub-freezing weather. That sounds interesting. That has something to do with freezing. Sub-freezing means below the freezing temperature, so freezing actually happens. How radioactive isotopes can be used to diagnose the condition of donated organs. Again, that doesn't have to do anything with freezing. So, although answer C does not involve organs, it involves insects, which are living things, which are made of cells. So if we can keep insects alive using special fluids in sub-freezing temperatures, that might give us information how to keep organs alive with certain fluids or similar fluids in sub-freezing temperatures. So therefore, C is a study that may shed light on how to preserve organs when frozen. Most animals have bodies that exhibit either bilateral symmetry or radial symmetry. If you drew a straight line down the middle of an animal exhibiting bilateral symmetry, the two sides would be a mirror image of the other. Such animals have a front end and a rear end. On the other hand, an animal exhibiting radial symmetry has a body consisting of similar parts arranged around the center. Circle the image of the animals below, displaying radial symmetry. So, that is only going to be one. If we look at the fly, we have one line of symmetry. So, that is an example of bilateral symmetry. We have a front and an end part. The same is true for the horseshoe crab. One line of symmetry. The same is true for the dogfish. We have one line of symmetry, front part and an end part or a rear part. The sea star has a center, and from here we have several lines of symmetry. So we have a radial symmetry, and yeah, so the correct answer is the sea star. Hydrogen peroxide molecules are composed of 2 hydrogen atoms and 2 oxygen atoms. Water is also composed of hydrogen and oxygen, but water has 1 fewer oxygen atom than hydrogen peroxide does. Which of the following statements best describes the chemical reaction shown in the equation below? Hydrogen peroxide is being made out of water and air. Hydrogen peroxide is decomposing into pure water. Hydrogen peroxide is decomposing into water and oxygen. Water and oxygen are combining to make hydrogen peroxide. So, what we have to understand here that this reaction shows a one or unidirectional process. We see hydrogen peroxide here, which is our reactant, and then we have an arrow here, which means it reacts to form water and oxygen. So the reaction goes that way from hydrogen peroxide. How do I know this is hydrogen peroxide, by the way? They tell us up here that hydrogen peroxide has 2 hydrogen atoms and 2 oxygen atoms, so therefore H2O2 must be hydrogen peroxide. Now water has 1 fewer oxygen atoms, which is just 1 oxygen, so H2O. The reaction goes that way. This is the reactant, these are the products. So therefore hydrogen peroxide is being made out of water and air. First of all, oxygen is not air, but it would mean different opposite direction as well, so A is wrong. Hydrogen peroxide is decomposing into pure water. What does decomposing mean? It means breaking down. Does the hydrogen peroxide break down? I would say yes. There's 1 substance, it breaks down into 2 substances. Does it break down into pure water? No, it does not, because oxygen is a product as well. So therefore answer C is probably the correct answer. Hydrogen peroxide is decomposing into water and oxygen. That sounds exactly what it is. Hydrogen peroxide reacts to form water and oxygen. It's called decomposition because it is 1 reactant that breaks down into 2 or more products. That's the definition of a decomposition reaction. Water and oxygen are combining to make hydrogen peroxide. That would be true if the reaction was written the other way around. If H2O plus O2 react to form H2O2, then answer D would be the correct answer. But it is hydrogen peroxide that is breaking down here. (14) refers to the following chart. So we see a couple of elements here, the melting point and the boiling point. Which of the following statements is supported by the information in the chart? Mercury and bromine are liquids at room temperature. Iron has a higher melting point than carbon. Iron has a higher boiling point than gold. Mercury, bromine, iron, carbon, and gold are all metals. Bromine is not a metal. Carbon is not a metal. So therefore, this answer is not correct. Now let's check the other ones. Let's have a look at the melting and boiling points. Iron has a higher boiling point than gold. Iron boiling point 5,000, gold 5,100, gold 5,300. So gold has a higher boiling point than iron, but the other way around. Iron has a higher melting point than carbon. Carbon with 6,000, definitely the one with the highest one here. So that means it must be answer A. Mercury and bromine are liquids at room temperature. And we know that room temperature is 25 degrees Celsius by definition. And we can see that they must be liquids because 25 degrees Celsius is above the melting point and below the boiling point. So therefore they are liquids. In 1969, the US Surgeon General announced that infectious bacterial diseases would soon become a thing of the past because antibiotic drugs had become so effective against them. However, since that time, strains of disease-causing bacteria that are resistant to antibiotics have evolved. Some types of pneumonia and gastrointestinal infections are now untreatable by antibiotics. About 17 million people worldwide still die annually from infectious diseases. Which of the following best explains why the US Surgeon General's prediction was wrong? Antibiotic drugs are not effective against most disease-causing bacteria. That's wrong. Antibiotic drugs are effective against most disease-causing bacteria. Infectious diseases are also caused by viruses and parasites. Infectious diseases have remained a problem outside the United States. Bacteria quickly evolved resistances against antibiotic drugs. So the best answer here is D, that relates to the text. What they tell us here is that since that time when antibiotics were developed, strains of disease-causing bacteria that are resistant to antibiotics have evolved, and the bacteria do this very quickly. So D is the correct answer here. A student did an experiment to see how far a ball would roll on different surfaces. She made 5 different ramps, each with a different surface. A plain pin board, a painted board, a board covered with sandpaper, a board covered with artificial turf, and a board covered with shag carpet. She set up his experiment on a smooth, level floor. To make the ramps, she raised one end of each board with a book. She collected 4 copies of the science textbook her class was using and set up 4 of the ramps with these books. She couldn't find a 5th copy of the book, so she used a thinner science study guide to set up the 5th ramp. She rolled the tennis ball down each ramp and measured how far the ball traveled each time. Then she compiled this data and drew conclusions. Why was the student's experiment flawed? The student should have used a ball with a smooth surface rather than a tennis ball. That would have changed the experiment, but it wouldn't have flawed the experiment, or the tennis ball does not flaw the experiment. Because we use the tennis ball, the same tennis ball in for every ramp. Therefore, it is a controlled variable, so that's fine. The student should have used books of the same height for all the ramps. That is the correct answer. By having one ramp that is lower, it is a factor that will affect our measurements and therefore falsify eventually our results. So all other variables except the independent variable, which in this case are the different surfaces, all other variables have to remain constant. They have to be the same, so that only the surfaces affect how far the ball rolls. 17. A solid rubber ball and a hollow rubber ball of the same size and material are dropped simultaneously in a complete vacuum from a height of 100 meters above sea level. Which ball will have a greater speed after falling 2 meters? The solid ball will have the greatest speed, the hollow ball will have the greatest speed. Both balls have the same speed. There is not sufficient information to determine which ball will have the greater speed. That might be a tricky question, but we need to know one thing. We need to know the effects of gravity on objects. And what gravity does to falling objects, it accelerates them. And the acceleration of gravity is usually referred to as small g, which is equal to 9.81 meters per second square. And you can see this is a constant. This is a constant value that applies to any falling object. So every object that falls experiences the same acceleration due to gravity, and therefore the 2 balls will have the same speed after falling 2 meters. The reason why this is the case here, and this is true from everyday life experience, you may say this can't be true. It's going to be the heavier ball that will have a greater speed, or the solid ball. That might be true, but what we have to take into account here is that this experiment is done into complete vacuum, which means air is absent. And the reason why in everyday life situations objects fall at different rates or speed up differently in the air is because of air resistance. Different objects experience different resistance force, which opposes the acceleration of gravity, and therefore objects falling in air are accelerating at a different rate. Since we are in a vacuum, all objects will accelerate at exactly this rate. A patient's blood pressure is 130 over 100. The first number is systolic blood pressure and the second one is diastolic blood pressure. Based on the diagram shown, would the patient's blood pressure level be considered low, normal, or elevated or high? 130 for systolic is right here, and 100 for diastolic so 130 over 100. Oh, come on, we draw a straight line, please. So it's definitely not normal, it's definitely not low, either elevated or high. And the correct answer here is high blood pressure. It's not elevated blood pressure. The reason for that is because the way that we read this chart is we're looking at the intersection of our two lines that we drew, and this intersection is in the high region, so therefore the blood pressure is considered high. The titration curve below shows the change in pH of a solution as a reagent is added. How many milliliters of reagent are needed to neutralize the solution? To neutralize a solution means to bring it to pH 7. So pH scale is on the left side. pH 7 is between 6 and 8. And again, we just draw our lines here to find out the volume that we need to add, and we can see that is 25 milliliters. Question 20 refers to the following paragraph and diagram. Herbivores are animals that eat only plants. Carnivores are animals that eat animals. Typical herbivore and carnivore teeth patterns are shown below. Here we have the carnivore teeth, some molars, premolars, relatively, and we have two large canines and the incisors in front. And in the herbivore, for example, a sheep, we see the incisors in front, and premolars and molars, and no canines. What is the most notable difference between the dog's teeth and the sheep's teeth? The dog teeth has fewer teeth than the sheep does. No, it doesn't. Probably more. Dog has molars and sheep does not. Both have molars. The dog has incisors and the sheep does not. Both have incisors. The dog has canines and the sheep has not. Yes, that is correct. The 5 largest asteroids, Ceres, Pallas, Vesta, Hygiea, and Interrania. The average distance from the Sun relative to Earth, so the distance from Earth
from the Sun to the Earth is equal to 1, and we can see that, for example, Ceres is 2.77 times further away than Earth is from the Sun. And their time to orbit the Sun in Earth years is shown here. Which of the following statements is supported by the information in the chart? Pallas is further away from the Sun than Hygiea. That's not correct. Pallas is closer. Of the 5 large asteroids, Vesta has the longest orbital period. Vesta has 3.6 years. That is the shortest. The 5 largest asteroids are all further from the Sun than Earth is. Earth is 1 unit away from the Sun, and we can see all of the 5 are more than 2 times further away from the Sun than Earth is. So C is probably the correct answer. Of the 5 largest asteroids, only Interamnia takes more than 5 years to orbit the Sun. No, that's wrong, because there are 2 that take more than 5 years to orbit the Sun. The American lobster, Homerus americanus, is typically bluish-green to brown in coloration. However, a rare genetic mutation estimated to occur in 1 in 2 million lobsters can result in a bright blue-colored shell. In 2011, 220 million pounds of lobsters, typically weighing 1 to 9 pounds each, were caught. 2 blue lobsters were reported in that time. In 2011, the experimental probability of catching a blue lobster was the estimated probability of a lobster having the blue mutation. So 1 in 2 million lobsters and 220 million pounds of lobsters were caught. They typically weigh between 1 and 9 pounds. So that means the average weight is around 5 pounds, more or less. So we can divide 220 million by 5 to keep it easy and simple. That is equal to 44. And that means this is more or less the number of lobsters that were caught in 2011. So out of 44 million lobsters caught, there were 2 blue lobsters reported. That means that usually 1 in 2 million lobsters is blue. That means we should have caught around 22 blue lobsters. So the correct answer here is less than. In 2011, the experimental probability of catching a blue lobster was less than the estimated probability of a lobster having the blue mutation. Based on the following diagram, so we see a volcano here and some labels. Based on the diagram, what causes a volcano to erupt? Pressure builds up inside the magma chamber and vent. Magma flows down towards the underground chamber. The lava plug at the top of the main vent wears away. The lava plug at the top of the main vent collapses inwards. So what we see here we have the lava plug on top, and they tell us that pressure forces magma up the main vent, and the branch pipes and hot magma collects in the magma chamber underground. So it's probably this information that is very important. So pressure builds up inside the magma chamber and the vent. Let's see what makes most sense here. Flows down, no, because of the high pressure, it will flow up.
The lava plug wears away would mean that bit by bit it wears away from top inwards. That is not what's happening. We don't get any information about that. The lava plug at the top collapses inwards, so it would fall inwards, but that doesn't make sense because there is a pressure force in the opposite direction. So the only answer that really makes sense is A, pressure builds up inside the magma chamber and vent. And this will then eventually blow the lava plug out when the pressure is high enough, and that is an eruption. In a chemical reaction, the atoms of the reactants are rearranged to form products with different chemical and physical properties. A catalyst is a substance that speeds up the rate at which a chemical reaction takes place. The catalyst itself is unchanged and the end of the reaction. In which of the following reactions is a catalyst at work? When an acid is neutralized, as when hydrochloric acid is added to sodium hydroxide yielding sodium chloride and water, that is just a normal chemical reaction, no words of any catalyst. When food is digested, as when an enzyme in saliva called ptyalin breaks down starch into sugars without changing itself, that sounds very good. When copper is oxidized by combining with nitric acid to yield copper nitrate, nitrogen dioxide, and water, so this is just a normal chemical reaction, reactants and products. And when baking soda is heated, causing the sodium bicarbonate to break down, yielding carbon dioxide gas as a byproduct, that is again a decomposition reaction, one reactants, two or more products, but no mention of a catalyst. So the correct answer here is B, and that's what an enzyme is defined as well. A simple definition of an enzyme is that it is a biological catalyst. Enzymes are proteins, specific proteins produced in cells that speed up the chemical reactions in our cells. They control them and they are not used up or changed by these reactions. For 5 years, researchers at the University of Wisconsin Medical School ran an experiment in which they evaluated the hearing of 3,753 people between the ages of 48 and 92. Of the group, 46% were non-smokers, 30.3% were former smokers, and 14.7% still smoked. The scientists found that smokers were nearly 1.7 times as likely as non-smokers to suffer hearing loss. The study suggests that age-related hearing loss might be preventable. Which of the following statements is most likely to have been researchers' hypothesis? So an educated guess that is formulated before the study is conducted. Smoking has been shown to harm health in many different ways. That is way too general. People can reduce their chance of developing age-related hearing loss by not smoking. That sounds very good. The University of Wisconsin study group consists of, that is not a hypothesis, and smokers were nearly 1.7 times as likely than non-smokers. Yes, that is the result of the study, but that's not a hypothesis. No? So a potential explanation, an educated guess. People can reduce their chances of developing age-related hearing loss by not smoking, and after this formulation is done, the study will be conducted, and it looks like they found confirmation for their hypothesis. So 26 refers to the following graph. Elements in humans and bacteria, the elements in humans in percentages and bacteria in percent. What is one of the main differences between the composition of humans and a bacteria? So we can see some different percentages. Humans have a little bit less nitrogen, hydrogen, a little bit more nitrogen. Other elements in humans are greater than in bacteria. Carbon is greater in humans than in bacteria. and bacteria contain quite a chunk more oxygen than humans. Humans contain elements other than oxygen, carbon, nitrogen, and hydrogen. Bacteria do not. That's wrong. Both have other elements. Humans contain a higher percentage of oxygen than bacteria do. Nope, it's the other way around. Humans contain a higher percentage of hydrogen than bacteria do. No, it's the other way around. And humans contain a higher percentage of carbon than bacteria do. That is correct. 27 refers to the following diagram. We see two simple machines here, where effort is produced to move a load. What do the wheel and axle and the screw have in common? Both increase the effort needed to move the load. No, simple machines usually decrease the effort that is needed to move the load by increasing the distance that the effort is moving, through which the effort is moving. So both involve effort applied with circular motion. That actually looks correct. Now this one is a circular motion, and the screw is a circular motion as well. So B sounds good. Both involve effort applied with a horizontal motion. No, we can see that is not true. Horizontal means along the horizon, on a flat line like this. That's not how the force is applied here. Both involve effort applied with a vertical motion. Vertical is the opposite of horizontal. And both have circular motion. So B is the correct answer. 28. During various periods in Earth's history, average global temperatures have dropped, resulting in ice ages. During an ice age, glaciers cover large regions of Earth. Scientists disagree about what causes ice ages. One hypothesis suggests that there have been long-term changes in Earth's orbit, causing the planet to periodically move further from the Sun. Another view proposes that a periodic increase in volcanic activity increases the dust in the atmosphere, blocking the sun's rays. Still another hypothesis suggests that changes in Earth's own radiation energy cause ice ages. And finally, other scientists propose that changes in the direction of ocean currents cause ice ages. So there are many potential causes of ice ages. Which of the following statements is a fact and not an opinion or hypothesis? During an ice age, temperatures drop and ice covers vast areas of Earth. That sounds like a fact. Changes in Earth's orbit cause temperature fluctuations and ice ages. This is one option. It's a hypothesis, but it hasn't been proven yet, so it's not a fact, because there are other options that might cause the ice ages. Again, we don't know yet. We still have to investigate that and find the answer to all these questions. Large amounts of volcanic dust blocking the sun's energy cause ice ages. Again, that is one option. So hypothesis. Changes in Earth's own radiant energy cause ice ages. Again, this is another hypothesis. So the only fact is that during ice ages, the temperature drops and ice covers vast areas of Earth. That is a fact. That's what the definition of an ice age is. So we have another diagram here. We see two chemical substances, C2H6O in this structure. The lines here represent covalent bonds by which the atoms are bonded to each other chemically. What is the main difference between the hydrocarbons ether and ethanol? Ether here, ethanol here. Ether has carbon, hydrogen, oxygen atoms, and ethanol has only carbon, hydrogen atoms. That's not true. Ethanol has an oxygen atom here, so that is wrong. Ether has 3 carbon atoms and ethanol has 2 carbon atoms. No, both have 2 carbon atoms. Ether has one oxygen atom and ethanol has two oxygen atoms. Nope, both have one oxygen atom. The arrangement of the carbon, hydrogen, oxygen atoms in the two hydrocarbons is different. Yes, that's correct. Now they all have the same number of atoms of both elements, 2 carbons, 6 hydrogens, and 1 oxygen. However, the oxygen is in between the 2 carbons in ether and directly attached to an outer carbon in the ethanol to carbon and hydrogen. That's the difference. In 1861, Charles Darwin, a naturalist who formulated the theory of evolution, remarked that the science of geology had made much progress in his lifetime. He wrote, about 30 years ago, there was much talk that geologists ought only to observe and not theorize, and I well remember someone saying that at this rate a man might as well go into a gravel pit and count the pebbles and describe the colors. How odd it is that anyone should not see that all observation must be for or against some view, if it is to be of any service. Which of the following statements best summarizes Darwin's view of the role of observation in science? Observation is the best way to gather facts about any aspect of nature. Observation is useful as long as it is supported by statistics. Observation should be used only in the field of geology. Observation is useful as long as the results are used to support or disprove a hypothesis. So the one that makes most sense is D. It follows the scientific method as well. So when an observation leads to the formulation of a hypothesis, and then an experiment being conducted, which in the end are observations as well, the data then supporting or disproving the hypothesis, then it is useful. Match each process to an example of that process. Okay. 4 types of processes that create minerals in Earth's crust are called magmatic, hydrothermal, metamorphic, and surficial. Magmatic processes involve the heating and cooling of magma deep inside the Earth's mantle to form crystals. Hydrothermal are caused by the movement of water within Earth's crust. Metamorphic involve combinations of heat, pressure, time, water, and various solutions to change existing mineral deposits and form new ones. And surficial processes are physical processes that affect rock at Earth's surface or in the loose material, solid and dust that covers Earth's crust. Wind eroding away the softer components in sandstone that happens at the surface. Wind only at the surface of Earth. Gradual increase in temperature in the mantle followed by a sudden drop in temperature. That's either metamorphic or magmatic. Movement of seawater, that is hydrothermal. Sea fault lines fracturing rock into particles underground, and then those particles undergoing great heat and pressure. Okay, that sounds like metamorphic, and magmatic is therefore B. Gradual increase in temperature in the mantle followed by sudden drop in temperature. Rainfall in 5 cities in California from 2008 to 2010. Rain in the first year, rain in the second year. In inches. Which city had the median increase in rainfall between the 2 time periods displayed in the table? median increase. Okay, so first of all of them increased. To find the median increase, so we have to calculate the increase for all of them first, which we can do by taking the numbers and subtracting them. So 62.77 minus 49.35 and so on. That will eventually give us a list of values, and these values we have right here. So this is the difference. And now we're looking for the median. The median is the middle value of a data set. Now, to find the middle value, we order the values from smallest to largest. So I will not write the decimals, we'll just round them to whole numbers. So we have 4, which is the first one here. This one is the second. 7, then third one, 13, then the fourth one with 15 rounded, and the fifth one with 18 rounded. So we can see that the median at the middle value is 13.42, and that is Crescent City. Brock's physics teacher has assigned everyone in his class the task of conducting an experiment. To write up the experiments, everyone must use the outline provided below. Match each summary of the steps in Brock's experiment to the appropriate category of the experiment outline. So again, we have our scientific method here: formulate a question about a phenomenon, collect data, or in other words, do background research about your topic, formulate a hypothesis, an educated guess, a potential explanation for your observation that can be tested by an experiment, which is step 4, and then based on the results of the experiment, we can draw a conclusion. So, if we look at D, Brock asked, does size affect the buoyancy of an object in water? That is a question that has been formulated. You can try this by yourself as well. We did this before already, so now is a good time to practice for the other steps. You can pause the video here if you want to do it by yourself. Otherwise, I will continue now. So next one, collecting data, doing background research. Brock noted that ice floats in water, whether it is a small ice cube or a huge iceberg. That is our background research. Now formulating our hypothesis. Brock thought, for an object made of a given material, increasing the size of the object won't affect its buoyancy in water. That is a potential explanation for an observation that can be tested. So increasing the size will not change the buoyancy, and that can be tested with an experiment. So E is our hypothesis. Then the experiment, Brock placed wooden cubes that were 1 centimeter cube, 10 centimeter cube, 100 centimeter cube in water. He observed the buoyancy. Then he placed iron cubes, 1 centimeter, 10 centimeter, 100 centimeter cube in the water, and observed the buoyancy. That is our experiment. And the conclusion drawn. Since all wooden cubes float and all iron cubes sink, size does not affect the buoyancy of an object in water. That is our conclusion. So the last 3 questions of this test. In 1993, after years of fluctuating water levels in the reservoir, The residents of Wayland County built a dam at one end of the reservoir to regulate and stabilize the water levels. Circle the X on the graph below that most likely represents 1993. So in 1993, after years of fluctuating water levels, they built a dam to regulate and stabilize water levels. So that has been done in 1993. We can see that here the water levels are fluctuating, and after point D they stay more or less stable. So therefore this is probably 1993. One property of a gas is that its molecules spread out to fill their container. Which of the following best illustrates this property of gases? A teacher's perfume can be detected at the back of the classroom. Rain puddles evaporate more quickly when the sun comes out. Water is produced when hydrogen gas is burned in oxygen gas. Liquid oxygen is denser than gaseous oxygen. So, gas molecules spread out to fill a container. The only answer that really makes sense here is answer A, the perfume. There's an aerosol, actually not a gas, it's like fine watery particles that spread out in the room like a gas by diffusion. B is about changing state, evaporation, what speeds it up, so not about spreading out, filling a container. This happens as well in the classroom. The classroom is a container in which the gas spreads out in. This is about chemical reactions, and this is again about properties of different states of matter, liquid and gas. The gravitational force between two celestial objects can be calculated using the formula F equals G M1 M2 divided by D squared, where M1 and M2 are the masses of the two objects, D is the distance between them, and F is measured in newtons, that's the force. We are not told what F is the gravitational force. We are not told what G is though. Let's see if we get more information. If the mass of the Sun is 2 times 10 to the power of 30 kilogram, the mass of Earth is 6 times 10 to the power of 24 kilogram. The distance, well, this should be to the power of, I guess, is 1.5 times 10 to the power of 11, which we need to square. And the gravitational, there we have it, is 6.67 times 10 to the power of negative 11. What was the gravitational force between Earth and the Sun? Yeah, this is probably something that we would just multiply out. And put that eventually in the calculator. So what we can do is we can rearrange this on top here a little bit to something like 6.67 times 2 times 6, and then put the 10 terms together. And then we need to square this out. 1.5 squared is 2.25 times squaring rule for exponents. 10 to the power of 11 squared is equal to 10 to the power 11 times 2, which is equal to 10 to the power of 22. So we can sum up the terms up there. Which would be 6.67 times 12. So if 30 minus 11 is 19, 19 plus 24. So if we multiply, there's another exponent rule. We have to add the exponents, so it's going to be equal to basically 10 to the power of 30 plus 24 minus 11. 54 minus 11 is 43, so 10 to the power of 43 over 2.25 times 10 to the power of 22. Now we can cancel this term out, and we are left with 20 times 10 to the power of 21. And if we multiply this out, we can put this in the calculator here. 6.67 times 12 divided by 2.2, and what we get from that is 35.57 times 10 to the power of 21. Now we move the decimal place to get it into scientific notation, which is 3.56 times, now rounded to 3 significant figures, 10 to the power of 22. Now by moving the decimal place here, we increase that number by 1. And that is the answer. And just really one that makes sense. So probably would have been enough to figure out that it's around 10 to the power of 21. Probably wouldn't even have to do this calculation. If we look at the answer options, the only answer that is close to 10 to the power of 21 is answer B. So that was the full science test. I hope I could help you with your prep for your GED test. I hope you're still there and made it through the whole video. And yeah, I hope I could help you, and I'm looking forward to see you in the next screencast, unless you have passed your GED Science test and don't need me anymore for that. I wish you all the best for the future and for your GED. Take care.